Hello everyone. Let's take a look at our next problem. Find the volume of the solid obtained by rotating the region bounded by the given curves about the specified axis. So the two curves we're given are y equals x squared plus 1 and y equals 9 minus x squared. And we are rotating around the axis y equals -1. Okay, so before I know exactly what technique we're going to use here, it'll help to sketch the curves and try to visualize what this solid of revolution looks like. There are two standard techniques for computing volumes generated by rotating an area around an axis. There's the cylinder method and the shell method, but I can never really. I think it just helps to draw a picture and then decide which of those two methods is more appropriate rather than having some kind of way of memorizing which one to use based on the form of your of the curves that are given. Okay, so let's sketch the two curves initially that define the area being rotated. X squared plus 1 looks something like this, at least for positive values of x, and 9 minus x squared looks something like this. This is absolutely not to scale in any way. I believe, so I'm only going to do this for positive values of x, but this area is the one that's going to be revolved around the axis y equal -1, but we're missing a symmetrical side here on the left, and so everything is just going to get multiplied by 2, but the main idea here is pretty clear. Okay, and we are rotating around this axis. So this is the curve y equal -1. So this region here, this area, is being rotated around y equal -1. And so the way I'm going to do this is using the shell method. If I imagine a thin slice of this region being rotated around the axis y equal -1, that's going to give me it's going to give me a ring with some area, which we should be able to compute. The way we're going to compute the area of one of these little rings, this is the inner area, or this is the, this is the radius of the inner area. It's the distance from the axis of rotation to the bottom curve. And then this is the outer area. This is the outer radius. And so we're going to have, basically we have a disk of this radius minus a disk of the inner radius. Okay, so let's imagine we have a fixed value of x. The outer radius is given by the curve on top, which is 9 minus x squared. And the inner radius is given by the other curve, x squared plus 1. So then the area of our rotated cross-section as a function of x is going to be 9 minus x squared minus x squared plus 1 squared, and all of this multiplied by pi. In fact, if I just write it as, if I write it this way, this is the area of the entire disk, and then this is the area of the inner disk, which is missing. Okay, and to get the volume of this entire shape, we want to integrate this area, a of x dx, So I need to find the value of x where these curves intersect. So I want 9 minus x squared equal to x squared plus 1. So this gives me 8 is equal to 2x squared, and so x is equal to plus or minus 2. So my bounds of integration are from -2 up to 2. So I have in fact included the negative values of x here. I'm not going to multiply this by 2. I haven't drawn it on the figure, but the other part of this figure, the other part of the two curves for negative values of x are now being included by putting this -2 lower bound. Okay, so let's write out exactly what integral it is we're trying to compute here. I'll put the pi out in front, and now I have 9 minus x squared minus x squared plus 1 squared dx. So the thing that we have inside here is just a polynomial. It's not in the nicest form as is, so I'll probably want to expand everything and then simplify and then just use standard techniques of integration. And I'm not going to explain all my steps here. I'm just going to go through the computations because they are in fact pretty straightforward. So this is what I get for the final volume, which, unless I've made some arithmetic mistakes or stupid errors around the integral, I'm pretty sure is correct. Yeah, questions like this, where we're rotating around an axis, really helps to just draw the curves and figure out what area itself is relevant, and that is being rotated around. And then once you see that, then I think it helps to just visualize what this shape looks like, and it becomes easier to identify whether you're going to use the cylinder or shell method. Thanks for watching.